Solving for these logarithmic equations is going to be, for me, like solving any other type of equation. It's just a matter of isolating the x and finding out what it's equal to. So here what I'm going to need to do is take the natural log of both sides. I could do base 10, but if I do the natural log, it's one less letter for me to write. Natural log of 5 to the 2x minus 3 is equal to the natural log of 3 to the x plus 1. I'm going to use the power rule and bring these exponents down. 2x minus 3 times the natural log of 5 is equal to x plus 1 times the natural log of 3. Now, in order to get the x, what I'm going to have to do is multiply these out and then get the x's all on one side. So 2x times the natural log of 5 now I'll subtract, get all the x's on one side, get all the other constants on the other side. Now on this side, listen, ln. On this side, I can factor out an x. And now I can divide this term out and leave me with just an x, and I will have my solution. And I could put this into a calculator and figure out what that is equal to. But I don't feel like doing that. So let me try a different one. I'll do three to the x minus 8 times 3 to the minus x is equal to 2. Now this one is a little bit trickier because I can't take the natural log of a negative number. So what I'm going to have to try to do is manipulate this and try to turn it into a quadratic problem, because I have the same base here. So let me go ahead and multiply both sides by 3 to the x. That'll be the easiest way. So multiply everything by 3 to the x. 3 to the 2x minus 8 times 3 to the 0 is equal to 2 times 3 to the x. So this will be equal to 1. 3 to the 2x minus 8 is equal to 2 to the 3x. Now I'm going to rearrange this for myself. Now to me it has become more apparent what I need to do, which is to make a substitution, where I'm going to substitute 3 to the x is equal to y. So if I make this substitution, I get y squared minus 2y minus 8 is equal to 0. And this is a problem I can solve quite readily and easily. Y, two numbers that multiply to be 8 minus 2 minus 4 y plus 2. So y is equal to 4, y is equal to minus 2. And now I resubstitute this back in here. 3 to the x is equal to 4. 3 to the x is equal to minus 2. And here I'm only going to have a single solution, because I can't have 3 to the x equal a negative number. I can't think of any numbers that are going to equal minus 2 when I raise it to some power. It's impossible. So this is not going to be a solution, and I'm only going to have one. I'm going to take the natural log of both sides. So the natural log of 3 to the x is equal to the natural log of 4. Use the power rule. So x is equal to the natural log of 4 over the natural log of 3. Might as well do a few more that look a little bit different. I'll do 4 plus 3 log base 2 of x is equal to 1. So again, I need to get the x by itself. I'm going to subtract this constant over 3 log log base 2 of x is equal to minus 3. Divide both sides by 3. Log base 2 of x is equal to minus 1. Here it doesn't matter if it's equal to a minus, because this is what the exponent is going to be equal to. It's alright if the exponent is negative. So now I have an exponential equation. I can convert this back to just regular exponential form. So I have x is equal to 2 to the minus first, and 2 to the minus first is equal to 1 half. And I have one more. That should be a bit more annoying. Log base 4 x plus log base 4 x plus 1 is equal to log base 4 x minus 1 plus log base 6, or log base 4 to 6. Whatever. So again, I need to find the x. I'm going to condense these, use the product rule. Log base 4 x times x plus 1 now what I can do, I can explain this to myself in two different ways. I can either say that this is a one-to-one function and that therefore this is in the form, well, I can think of this as in the form of log base 4 of some x is also equal to some log base 4 of some x. And I can say that these two inner terms are equal to each other, and I can just set them equal to each other. Or what I can do is just do the inverse. I can just put everything as an exponent of base 4. So I can say base 4 log base 4 x plus 1 is equal to 4 log base 4 6x minus 1. And this is the way I usually think of it. But I think of it this way sometimes too. In fact, this way I would have just thought of it this way. But more often than not, I'm going to find this method more useful, at least in differential equations and such. So these are going to cancel out because they're opposites of each other. I'm going to get x times x plus 1 is equal to, and then these are going to cancel out because they're opposites of each other. They're a function and its inverse function, so they'll cancel out. 6x minus 1 x squared plus x is equal to 6x minus 6. And now this is just a basic quadratic problem. I can use quadratic formula if I want, but this is simple enough. So minus 3. Now the only thing that remains for me to do is to check and see if both of these numbers are in the domain. So what I'm going to do is I'm going to put 3 back into this equation and see if I get any problems with the domain. So I'll change that. So let me write it here. So log base, or I'll write it back down here, whatever. So let me check this one first. Log base 4 of 3 plus log base 4 of 3 plus 1 is equal to log base 4 of plus log base 4 of 6. So if I do this math, what I'm looking for is to see if I'm going to be taking the log of a negative number. If I'm taking the log of a negative number, then it's not in the domain. And not a solution. So here I have a positive number, so that's fine. 3 plus 1, that's a positive number. 3 minus 1, that's a positive number. And 6, that's a positive number, so that's fine. So 3 is a solution. Now it's pretty easy to see that 2 is going to be a solution, but whatever. Let's go through the process. Log base 4. put in 2 for x. This is a positive number, this is a positive number, this is a positive number, and this is a positive number. So this is also a solution. But had any of these been a negative number for 2, then 2 would have not been a solution. But that's all that really needs to be done for this type of logarithmic expression or logarithmic equation that I'm solving for, is to check and see that if my solutions are in the domain.